Hey guys, welcome back. So in the previous video, we talked about pros and cons of linked list. Hope the idea was clear. In case if you have any doubt, please feel free to ask those in question and answer section and we will get back to you. In this video, we are going to compare a linked list with other data structures. So till now we have learned only array and linked list. So we are going to compare only linked list and array as of now. In the future videos, when we learn other types of DS, we'll compare those with linked list and array as well. So whatever we are going to learn in this video is nothing new. It has already been taught in linked list and array videos. The purpose of creating this video is to summarize all the things that we have learned till now in one matrix. This will help us to compare different data structures as well as to remember the concept in an efficient way. So we'll not spend much time on this matrix, we'll quickly walk through this. So the first item here is insertion at kth position. Now what does that mean? That means is we need to insert data at a predefined position. Let's say we want to add a new data at third position. Now in case of an array, we can directly traverse till the third position, which can be done in constant time. But the problem is the rest of the data, that is 40 and 50 in this case, needs to be moved one cell towards right, which will take order n time. Now coming to the linked list part, in case if we want to insert the data at third node, we don't have a direct way of reaching till the third node. The only way is we need to traverse from first and keep on going towards right and reach the third node. So that operation of traversing from first node till the third node will take order n time. Once we create a new node at third position, we don't have to do any processing for rest of the node, that is 40 and 50 in this case. So both array as well as linked list will take order n time. Next item. So in case of an array, if we want to insert some data at first position, we can reach till the first position in constant time, but rest of all the data needs to be shifted towards right by one cell. Hence the time taken for this operation will be order n. In case of a linked list, if you want to add a new node at the beginning, all that we have to do is we have to create one more blank node over here, insert a value here and just link it to current first node. This entire thing can be done in constant time, hence the complexity is order of 1. Next item, insertion at last position. So in case of an array, if we want to add a new data at the last position, it can be done in constant time. Why? Because all that we have to do here is we have to insert a new value, no further adjustments of existing cells are required. Similarly, in case of linked list, if you want to add a new node at the last, it can be done in constant time because our tail pointer is already pointing to the last node of the linked list. Next item, deletion from kth position. Say for example, if we want to delete the third cell value of this array, which is 30, then reaching till cell 3 will take us constant time, but shifting rest of the data, that is 40 and 50 in this case, towards left will take order n time. Hence the complexity of this operation is order n. In case of linked list, if we want to delete say 30, then we need to start traversing from first and go towards right till we reach the third node, and then we can delete this node. So to traverse from first to third node will take order n time, whereas we don't need any adjustment for rest of the nodes, which is 40 and 50 in this case. Hence the total time taken will be order n, which is for traversing from first node till third node. Next item, deletion from first position. Now if you want to delete the first cell in an array, which is 10 in this case, it can be done in order 1 time, but the rest of the cell, that is 20, 30 and 40 and 50, needs to be moved one cell towards left, which will cost us order n time. Hence the total complexity for this action will be order n. In case of linked list, if we want to delete the first node, it can be done in order one time because there is no modification required for rest of the cells. We have to just delete the first node and update the head pointer to point to number 20. Hence the complexity is order 1. Next item, deletion from last position. So in case of an array, if we want to delete the last cell, which is 50, it can be done in constant time. All that we have to do is delete the value in this cell, and there is no adjustment required for rest of the cell. So the time taken for this operation will be order 1. In case of linked list, if you want to delete the last node, it can be done in constant time. But the problem is that to update the tel reference, we have to traverse once again from start and go till node 40. So traversing from first node till node 40 will take us order n time. Hence the complexity of this operation will be order n. Next item, searching in unsorted data. Assume that our array is having unsorted data. In that case, if we want to search for a particular data, since there is no order in which data has been input, hence we have to travel from first cell and go towards last cell till we find our data. So this operation in the worst case will take order n time. Similarly, for linked list, since the data is unsorted data, so we have to traverse from first node towards last node and keep traversing till we don't find the desired data. Hence, this operation will also take order n time. Now the next item is accessing a data. Now what do we mean by that? It means that if you want to access any data at any specific location, say for example, we want to know which data is stored at 4th position, which in this case is 40. So in case of an array, it can be done in constant time because all that we have to do is we have to say ARR of 3 and the system will return us the 4th cell value. But in case of a linked list, we don't have any such facility. So we have to traverse from the first node and move till we reach the 4th node. So this will take order n complexity. This brings us to the end of this video. So in this video, we learnt about how different operations have different time complexity depending on which data structure we choose. Hope the concept was clear. With this, we end this video. Thank you. See you in the next video.